All right, welcome everyone. Thank you for coming to Uplink 2014. We're happy to have you. My name is Jill Abasto. I'm with Qualcomm Incorporated. First, I just want to make sure that you're all in the right session, that you know where you are. Today we're doing developing on the DragonBoard Platform and Internet of Things Development Kit. And we have Victor Gonzalez here, the Senior Director of Engineering Services with Intrinsic Technologies Corporation. I want to give you a quick reminder that if you could silence your cell phones, please, that would be great. And make sure at the end of the session that you fill out a session survey on the conference app for the opportunity to be one of the 14 winners of the 32-inch LG Smart TV. Those drawings will be held in the Golden Gate foyer each day, today at 5:30, and tomorrow it's at 5:05. That's all I have before we get started. I do ask that you guys hold your questions to the end. There will be time for a Q&A at the end of the session. And with that, I'm going to turn it over to Victor.
Welcome, everybody. So I'm going to be talking about the development platform, the DragonBoard development platform with the Snapdragon 800 series processor, and the companion board, the Internet of Things adapter board. So I'm going to give you an overview of the Qualcomm Snapdragon processor, start off with a bit of an overview of the technology, why you'd want to use it, some of the great capabilities that are associated with it, some of the tools, peripheral capabilities as well, and go into more detail on some of the value adds that you can get by using it with the development platform that is the DragonBoard, and get to the Internet of Things adapter board and what you can do with it. So a bit on the agenda. This is just a diagram of the development platform for those who are not familiar with it. That's the Snapdragon 800 series DragonBoard with the APQ 8074 processor, and the smaller photograph of the Internet of Things development kit I'll speak to, and it's shown there with already mounted with the Arduino shield and motor. So Snapdragons, as you've heard in many of the sessions today, keynotes, very powerful processors, leading edge, used in so many mobile devices out there, that it'd be great to be able to leverage them beyond what's just available inside your cell phone to be able to use them in other embedded products. So for embedded developers, it still can do a lot of capabilities in an embedded product in terms of computer vision, multimedia, and so many other capabilities that are present in the Snapdragon processor. And it's great to have it available in a development kit that broad market can purchase, use, and leverage the capabilities of that technology. So there's a lot of technology built into the Snapdragon SoC. Besides the CPUs on the 800 series, as I'll get to in a minute, there's the quad-core crate processors. On the DragonBoard, they're running at 2.1 gigahertz. So that's a lot of processing powers just in itself, but there's a lot of other capabilities as well. The Arduino GPU, great graphics capabilities there that you can leverage for video processing, video acceleration. The Hexagon DSP, you can sign up for a Hexagon development license at developer.qualcomm.com and go through the links there to leverage the capabilities of the DSP that are built into the Snapdragon. As well as the camera subsystem, very powerful ISPs, dual ISPs to be able to do multiple cameras working concurrently and very, very powerful for various different computer vision and other applications using video processing. But also the Snapdragon has available a lot of IOs, a lot of other interfaces, and on the DragonBoard it exposes them. And through the Internet of Things, you can leverage them to control a variety of different types of devices, as you'll see. Internet connectivity through Wi-Fi and Bluetooth is also very powerful, and Internet of Things is very important to be connected, as that's been a very prevalent theme throughout today that's been discussed, and it's no exception in the case of the DragonBoard Internet of Things. Also, we supply on the DragonBoard plenty of memory left over for application developments for your custom applications. Location services, GNSS is also supported. So with all of these various different capabilities, there's a lot you can do with the Internet of Things, whether it's multimedia, number crunching with DSP, video processing through the camera subsystem, and do it all in an efficient, low-power fashion with the great power management that's available and proven in the mobile processor market that you see today. And and to simplify things at the high level, you can do this with a high-level OS like Android, which provides a rich set of APIs available. So there's a lot of Snapdragon processors available from the 805 down through the 600 are listed here on the presentation. In terms of what I'm going to be talking about today, I'll be talking about the Snapdragon 800 on the DragonBoard 800 series. So as you can see, it's a quad-core Crate 2.1 gigahertz processor, Arduino 330 GPU, plethora of different peripheral interfaces to give you the ability to have high-speed interfaces to and from the processor, get your internet connectivity happening through very broad pipelines. And the kit's available today. So
800 is for tablets.
800 can be used for various different applications. The 800, so your question was, is the 800 available only for tablets? The 800 is available for lots of different embedded applications, and that's where one of the benefits it exists of the DragonBoard development platform. It's available there for anybody that wants to take a Snapdragon embedded into their product. Could be robotics, could be multimedia. There's a lot of different markets you can target besides tablet. And through the DragonBoard program, you can go and purchase it and experiment for your own applications. Tablets is one of them, but doesn't have to be limited to that. So some of the development tools in terms of this Snapdragon processor itself, there's, of course, the SDK for Android to be able to take advantage of the Snapdragon capabilities that are unique and differentiated for Android from Qualcomm. There's also, you may have seen some of the presentations on augmented reality with the Qualcomm Vuforia SDKs to be able to take advantage of some of that vision processing and other capabilities that are available through the augmented reality. Context awareness, peer-to-peer, which is used in the all-join service for peer-to-peer communication, is used for the connectivity, the internet connectivity for the Internet of Things on the DragonBoard, as we'll get to later, but that's very easy to use peer-to-peer service and very easy to have a bit of an example and try it out with what's delivered with the Internet of Things for the DragonBoard. In terms of other vision capabilities, image stabilization and other computer vision capabilities can be leveraged using FastCV and the FastCV SDK. So it's an optimized computer vision library for the Snapdragon, available from Qualcomm and available and supported on the Snapdragon processor, including the DragonBoard. In terms of power profiling, very handy to have a profiler to see where bottlenecks might be in your software if you're doing application software or even middleware software for your library and you want to figure out where's the bottlenecks in your system. Trepin's a profiler from Qualcomm, and it works really well to identify CPU utilization, what's the CPU frequency, and with that you can identify and optimize the performance of your application to make sure that it's using all the different cores effectively and offloading the cores for media processing and multimedia playback effectively and and using the system resources wisely. And of course, the GPU, the Arduino SDK and Arduino profiler is available as well for the multimedia. Particularly gaming it's helpful for, but any of the multimedia capabilities for graphics processing, it's very useful to support as well. So the DragonBoard, I've mentioned it a few times already. So basically, there's a picture of it here. It's a development platform available, and you can see it at the exhibit booths as well. And basically, it's the Snapdragon processor available on the computer, on the system on module. And with that, you're able to experiment on this platform for your own development purposes and use it as a reference platform. But it's also designed in a modular fashion, so you can take the CPU and the system on module. Yeah, sure, go ahead.
What would the cost be to the individual consumer?
So it depends on the volume of how much you'd like to purchase, but the development kit for the DragonBoard development kit is $499. And the system on module is available depending on volume for different prices.
$499?
For the complete development kit. For the DragonBoard. Yes, which you see there. So with that, you've got all of those capabilities on the Snapdragon processor that I talked about earlier, and it comes with Android, and you can do development on it for your particular application. And as you can see, there's a lot of different headers that are broken out, that break out a lot of different interfaces, whether they're SPI buses, USB, GPIOs, HDMI. There's a lot of different interfaces that are broken out. And this one's based on the Snapdragon 800 series, the APQ 8074.
Can it be flashed with another, I guess, no, it's embedded, right?
So the DragonBoard platform, when you buy it, you get it delivered to you with Android already running on it. And we also provide a link to developers where they can download a software release for it. There's several releases available already for the DragonBoard, but they're all basically the same. You download the software, you get the binaries that you can flash onto the device, or you can take a look at the source code that's provided and run the script. It'll pull the source code from Code Aurora on a specific manifest and apply the patches for the specific peripherals that are unique to the DragonBoard. It kicks off a build for the image, and then you can use some standard flashing tools like Fastboot to program the board with your image. So it's a well-rounded development platform that allows you to do development, but as I'll get to on the Internet of Things, there's still a bit of, has been some demand to help people get started with Internet of Things development, where we could still help them a little bit further, and that's where the Internet of Things development kit comes in, and we provide a little bit more to help them get moving with their development for Internet of Things. So just going into more detail on what's available on the DragonBoard development kit, it's got the, what's shown here is a picture of the development kit with the display connected to it. The system on module has the processor, Wi-Fi, power management chip, and eMMC that it boots from. And the rest of the peripherals are off board. In terms of what's available in terms of documentation that's provided, we get questions about what documentation is provided. We provide a set of documentation on hardware, and that includes things like the bill of materials, technical notes. What if you wanted to build your own carrier board or motherboard? We provide pinouts, schematics, that kind of information, so that you can take that Snapdragon processor and build your own motherboard and create your own product around it and go to market with your own embedded product with a Snapdragon in it. So the hardware set's very important to be able to give some of that guidance, schematics, bill of materials, part numbers, manufacturing numbers, those kinds of things. So the display is not included in $499. The display is an extra component, but the rest of it, as per the previous picture, was included.
Qualcomm
Yeah, the black display board.
So you could put another
Well, if I go back, this is what it would look like without the display there. And so that's what you get for the $4.99. And so as you can see here, there's a display connector here that it plugs into, that the display would plug into. So we provide the schematics, and the display driver is available in source. And so you're able to design your own display driver. So it's more for ecosystem partners that I have a display I want to build and test it out with the Snapdragon and see how well it works. You could buy a DragonBoard and test it out, design your own display driver.
So it's display independent. I could build my own display and go there, see if it do the software hardware integration.
So the hardware comes with schematics and bill of materials. So you can see how we got our display to work, and you can follow a similar design path, and you have a good reference to start with to design your own display or display driver to be able to have something that's compatible with the Snapdragon processor and take advantage of its high resolutions and frame rates and capabilities for the display interface. In fact, that interface here for the display connector actually brings out both MIPI DSI interfaces for two displays. So if you really wanted to, you could have dual display running here. In our case, for the board that we're producing, we only have one display available to be able to connect to it. But there's nothing to stop somebody from taking the same schematic information for both MIPI display interfaces, designing their own display board, two of them, if they wanted to connect to the one connector. Other information that we provide with the kit GPIO configuration information. It's very important to know how you configure your GPIOs. The Snapdragon processor is very flexible in the multiple pin configuration, and so we provide the default settings that we for the hardware that's provided for the DragonBoard in terms of the GPIO configuration. And various other documents, some of them several thousand pages because there's a lot in the Snapdragon that you can design to and program registers. So there's a lot of detail that's provided there for the Snapdragon processors to allow you to do the low-level configuration of some of the hardware. And as well as the standard things you would expect in any development kit, being able to have release notes, set of features, what's supported, what's still in the works, what's any known issues, and so forth. So those are some of the kinds of things that we provide. So just to go into a little more detail on what the Snapdragon 800's processor supports. So as I mentioned, there's two parts to the development kit. There's the system on module, and then there's the carrier board. So on the system on module, we support, of course, the processor, the power management ICs, and memory. We support 2 gigs of RAM, 16 gigs of eMMC. We boot from that eMMC as well as have a user data partition to allow you to use that to store your files persistently. As I mentioned, we have 2 MIPI, well, this one's I didn't mention, but the 2 MIPI CSI connectors for cameras. So on the system on module, you can connect multiple cameras, and the processor itself has 3 MIPI CSI interfaces, 2 of which are brought out to the system on module, and a third one is brought out to the carrier board. So give you some flexibility in how you'd like to arrange your camera connectivity. In terms of Wi-Fi, dual band Wi-Fi, it's a combo Wi-Fi Bluetooth module. GPS is also supported on a separate chip, but on the SOM, it ships on the SOM. We have a couple of additional board-to-board connectors besides the edge connector. That's the larger Q7 form factor edge connector. We have 2 board-to-board connectors underneath the system on module, and that just exposes additional pins because there's so much I/O and capabilities on the Snapdragon processor. We really wanted to bring out as much functionality as possible out to the carrier board for you to be able to utilize it. And on the carrier board, we picked a wide breadth of interfaces to support. We brought out 2 USB 3.0 Type A connectors, gigabit Ethernet as well. one of the things that we found is very popular is there's so much data that the processor can handle when you're talking high-resolution cameras, a lot of video you're capturing and streaming. You got to have a fast way to get it in and out of the out of the computing modules. So some of these high-speed interfaces, like Gigabit Ethernet, USB 3.0, very convenient for those kinds of things. Support power, of course, DC in, a 12-volt power supply, and HDMI for output. We have audio support, USB 2.0 through the micro AB connector for USB 2. We support reflashing the software, as I mentioned earlier, and other SMA connectors for other antennas. Yeah, so those are some of the interfaces available. So I think I talked a little bit already about some of the advantages of the development kit. There's a lot of there's a lot of demand to be able to have the Snapdragon processor embedded into devices out there, and it's not always a cell phone or a tablet that you're finding them, although that is a lot of the places you find the Snapdragon processor. But you can build it into robots, as you've seen in the keynote today, and other systems. And so there's great avenues here to be able to leverage the Snapdragon processor and get it developed into your product. There's also good support that's provided with it too on the mydragonboard.org community site. So you can go there and see what kind of questions other people have had about the platform and been answered, and post your own questions as well. And it's a bit of a community with a lot of other Snapdragon embedded platform owners contributing their knowledge and feedback and building a good ecosystem for good support. So I already talked about software updates and software upgrades. You're welcome to use a lot of that, rebuild the software yourself, rebuild the BSP and the kernel, and download it over again with your own customizations. So it's quite flexible in that regard. In terms of software performance profiling, so one of the performance tools we talked about, Trepen, can be used for profiling the CPU and seeing the benefits of or seeing how you can optimize the operation of your software using that profiler. Of course, because this is a bit of an open platform, you have a serial port. You can also connect to the serial port, go to the file system, and go through the SysFS interface and just dump what's under the /CPU proc and see what's going on in terms of frequencies and so forth. So it's quite an open system, and it has to be as a reference platform, and lets you get down to the low levels as well to see the CPU performance, go and just adjust the CPU frequencies, lock it down if you don't like the certain algorithm, and change the CPU scaling points. So there's a lot of flexibility in what you can do here, much more so than just a commercial device. Here you've got the flexibility. And especially for embedded products that are a little bit different than the standard phone and tablet, you might want to have the frequency models adjusted a little bit differently for your particular product. Maybe it's not battery powered, maybe there's other reasons that you might want the frequencies to work in a different fashion. So yeah, I think I talked a little bit already about being able to repackage that system on module into other products as well that you might want to bring to market. So the SOM approach makes sense from the reusability. You have a proven system on module. You can do a lot of the development on that. Even start your development while you still have your hardware team go and create a carrier board or a motherboard for your product, and get your software development going and not be blocked by lack of hardware availability. So one of the things that people would like, despite that being available and the documentation being available and the community site being available, we still want to try to make things as easy as possible for people that are interested in the Internet of Things. So one of the most popular platforms out there on the Internet of Things, the Arduino Shields and Arduino development environment, is out there, and there's already a lot of peripheral boards that are supported, a lot of these Shield peripheral boards. So one of the things that we have done with the DragonBoard is to bring out some of the interfaces that an Arduino Shield could benefit from, and try to leverage some of these other boards that are already available out there. And why not just have an adapter board that you can have an Arduino Uno or type Shield connected to, and be able to control LEDs, motors, and other things. There's a lot of processing capability in the Snapdragon processor, and just because we're targeting control of low-level items like LEDs and motors and so forth, doesn't mean it's not a good opportunity to take advantage of the Snapdragon's strong capabilities. We've been to other shows in the past and shown where FastCV might be useful for computer vision and detect something and take a picture. So taking a picture is not that difficult, but there's a lot of processing beforehand that might have to take place where you're doing a lot of processing that might trigger that event. Similarly with the robots, there's a lot of processing that takes place in a lot of that neural networking or neural processing software to have that artificial intelligence or learning experience that Brain Corporation displayed at the keynote today. So there's a lot of processing that could go on in the background, and then still be nice to be able to control the motors. So there's still a lot of great applications that you can leverage on the Snapdragon with the Internet of Things. So in this case, what we decided to do is also tie in another technology from Qualcomm, or the Alcine Alliance, the All-Join API set. And in this case, you can, what we decided to do is provide an adapter board with an Arduino Shield, with a motor shield specifically, and be able to communicate between a tablet that might have All-Join API-based application running on it with its peer-to-peer service, and communicate wirelessly with the platform here running Android as well on the DragonBoard, and have it control some of the motors and other Arduino-based peripherals hanging off of it. And so that's what we put together. We made it available on our website, so you can take a look at it. We also have it on demo downstairs in the trade show, the exhibition booth. So you can take a look at it and give you something that out of the box you have source code for, you know how it works, you have a great example of the All-Join peer-to-peer APIs being used, and we give you the details for the adapter board, and you can use that as a good out-of-the-box, already works. You have something that does motor controls and is available here, and just enhances the development flexibility of the DragonBoard. So this is a diagram of the connection. You can see here that it's powered in this case via USB. So there's a connector on the side that provides power here. It's not the only way to power the board, the Internet of Things adapter board, but that's one way. You can also power it from an external power. And it's very easy in this case because we just applied power from one of the existing USB 2.0 ports available on the DragonBoard, so that's where it's getting its 500 milliamps of power for this particular application with this Arduino Uno motor shield. So in this case here, we can see that it's connected to the sensor header on the DragonBoard. So the sensor header on the DragonBoard brings out the ribbon cable over to the adapter board, and the adapter board has the Arduino headers, and we plugged in an Arduino shield. So yeah, there's a lot of different buses and interfaces that are supported through this interface, and we bring out a number of them for the adapter so that you can have both output and input through buttons as input, and have SPI and various other interfaces to communicate with it. So a bit of a more close-up view of the adapter board, the Internet of Things kit. So what does the kit comprise when you buy it? You get the adapter board, the motor shield, which is an off-the-shelf product, the ribbon cable to connect the two from the adapter board to the DragonBoard, USB cable. We give a sample DC motor, and we provide the applications and code and user guide. So, yeah. So how do the systems communicate with each other? Well, the implementation that we provided has two APKs, two Android applications. We have the Android application on the Android device, could be a tablet or a phone, running the sample application, the Internet of Things sample APK. And it's communicating with the DragonBoard over Wi-Fi using the all-join peer-to-peer API set. From that point, the DragonBoard-based application, and those are just simple commands going over the all-join interface, but enough just for demonstration purposes so that you can see how it's done and take it to any further level that you might want to customize. And then the Internet of Things application, the demo APK, that receives the all-join commands will receive those commands and send them through to an Android service, another application, but a service running in the background with the right permissions levels for a system ID, user ID, permission level to be able to access some of the low-level devices on the platform. So it'll communicate across through to the Android service that's also provided, and yeah, so that one will be able to communicate with over I2C and GPIOs with the hardware. So things like a sysfs type file system access. So what do we provide? We provide the binaries of the APKs just so you can get it out of the box and it'll work properly. We also provide the source. So we provide you documentation where you can find it. It's already on Code Aurora today, so you can take a look at it today. Even without buying the kit, you can certainly take a look at the demo applications in source form and build them yourself. The user guide we provide gives you more details about adding the all-join libraries to your application so that you'll be able to use the peer-to-peer APIs properly. So what kind of APIs are there in the application? So we have messenger service APIs. We provided some samples. It's not a large body of code, but it's enough just to give you a bit of a taste of what you can do with all-join. So we bind to the service and obtain the messenger. And we send instructions to set GPIOs, and we specify the GPIO number that you want to set, or we specify whether you're setting it high or low, or input or output, all the details for the GPIO that you need to configure. We can also get the same information as well as set it. And for I2C, we provide information there on how to communicate messages over I2C to the specific peripheral that you're trying to target. And so we'll just send binary bytes that we can send across in strings. And that's simple primitive to communicate across those APIs. And as I mentioned, well, there's the URL for accessing the source code if you want to take a look at it from Code Aurora. So this example setup is basically what I've got set up downstairs at the exhibit hall. We've got the tablet running the sample APK, and it's communicating wirelessly with the DragonBoard. And the DragonBoard's got on its display the same information that's shown on the display on the tablet. And when you use the tablet to request, for example, turning on one of the LEDs on the matrix here, it'll communicate over I2C, send the message across, and set the LED.
Communicates over what?
Wi-Fi. It's Wi-Fi all-join service. So this is the all-join peer-to-peer service between the tablet and the DragonBoard. And its transport is Wi-Fi.
So the tablet is what? Is it a connected device with the Snapdragon?
The tablet device, in the case I've got downstairs, it's with the MDP Snapdragon 805. Sure. So this is an example of the configurations of all of the parts in place to demonstrate from one side of the AllJoyn API from the tablet communicating with the DragonBoard, and it has the IoT board driving hardware peripherals, including a piezo buzzer, LED matrix, and a fan. So you can control all of those peripherals from the tablet remotely with, over Wi-Fi.
So the proxy here is the Snapdragon board. That's
Right.
controlling all of those three things: the fan, the LED, and
Right. So the Snapdragon board is receiving the commands from the tablet and sending the commands via that ribbon cable to the Internet of Things board.
So at the consumer level, they would let's say the consumer wanted to wake up in the morning and their phone will, as soon as they woke up, they wanted all the house lights to turn on. So they would need to purchase an adapter device that would sort of then be connected to the lighting system of the house, right?
Sure. So there's a lot of ways to do that. So your question was, how would a consumer turn the lights on in their house themselves?
Wakes up, their phone has the alarm. They wake up in the morning and they want all the house lights to be on.
Sure. So if the consumer wants to have all the house lights turned on, there's a couple ways to do it. Obviously, there's timers in Android. You can set a timer on, toggle a GPIO, and the GPIO could go and switch some hardware to turn lights on or off. However, say you're not there and you wanted to do things remotely and take advantage of the connected Internet of Things. So you could use some kind of service over a data network, and AllJoyn peer-to-peer networking certainly can be used over a wireless network, and be able to, from your phone or tablet, turn on or off the lights in your house or something like that if you wanted to, or control any other piece of hardware, blinds, security cameras, whatever you wanted to do. It depends. You have to certainly take into account security and make sure that you're using a secure connections. Yeah, secure connections have to.
Somebody could just access your home.
Yeah.
To your home easily.
Yeah. So there's certainly security is something that needs to be taken into account, but there's nothing to prevent you from implementing secure connections over this and implement your peer-to-peer service over secure connection.
There's a Q&A after the session.
Sure. So let me just wrap up a little bit. So basically, for our Internet of Things platform, feel free to visit our booth downstairs. You can see a demo of everything that I've talked about today working downstairs. You can go to Intrinsic's website, take a look at our Internet of Things. You'll see some more documentation on what's involved here, some of the products I've talked about, and yeah, call you to action to begin your development. So thank you very much for your time. If you have any questions, can you please speak at the microphone, just because I know that they're recording the event. Thank you.